So one of the tasks we're going to be asked to do is to write the equation of a tangent line. And just to make this easier on ourselves, I wanted to take our normal formula for writing an equation of a line and rewrite it using the derivative, or using the notation of the derivative, so we know how to make connections between the derivative and a tangent line, specifically the equation of the tangent line. Alright, so let's say we have a function, let's call it f. Then if you remember, we use the notation f prime to be the derivative of the function. And again, just to make the connection, the derivative is also the slope of the tangent line, or you could call it the instantaneous rate of change. So anytime you hear the word derivative, you can be thinking of the slope of the tangent line or the instantaneous rate of change as meaning the same thing. Okay, so we have our function, we have the derivative. How do we find an equation of a tangent line? And specifically, we're not just finding any tangent line, we want to know the tangent line at a specific point x equals a. So the tangent line is different depending on which point we're looking at, so we always need to specify which point we're making the tangent line for. So let's start with our point slope form. We normally have y minus y1 equals m times x minus x1. So here, the specific point we are looking at has a as the x value. So on the right-hand side, for x1, I'm going to replace it with a, and I have m times x minus a. Then on the left-hand side, instead of y1, I'm going to write f of a. So if a is the input, f of a is the output, or the y value that goes with it. So the last bit we have is this m value that we need to replace with something. So m is the slope of this line. This line is the tangent line at x equals a. And the slope of the tangent line is the derivative at that point, or f prime of a. So, putting this all together, we have y minus f of a equals f prime of a times x minus a. So this is my final equation for a tangent line at a point x equals a. And just to highlight something, normally we write our final answers as y equals, so we would need to move that f of a on the left-hand side over to the right-hand side, and you'll get to see what that looks like in the next example. Okay, so before we practice writing the equation of a tangent line, I'm just going to give you an equation of a tangent line and have us unpack the components a little bit. Okay, so let's say we have a function f, and it has a tangent line at x equals 4 with the equation y equals 6x minus 21. So we know that on our function f, we're at the point x equals 4, and at that point, the tangent line is 6x minus 21. So with this, there are two questions I want us to answer. The first is, what is f of 4? And the second is, what is f prime of 4? So this is a good time to pause the video and give this a shot on your own. This is the first time we've done an example like this, so it might be a little challenging, but please pause now and give it a try. Okay, so starting with f of 4, I like to think of f of 4 as the output that goes with the input of x equals 4. So how are we going to find this? Thinking of the graph, we don't know what f looks like, but we can draw a sketch just to help us out here. We know that on f, the input of 4 will have some output, and we're trying to figure out what that output is. The only information we have is the equation of the tangent line. And the purpose of the tangent line is that it touches the function at that point x equals 4. So we can use that tangent line to find the output, the y value that goes with x equals 4. That output will be on the tangent line, and it will also be on the function. That's our f of 4. So to find that value, let's substitute 4 into the tangent line. So we're going to replace x with 4, and we have y equals 6 times 4 minus 21. That's 24 minus 21, which is 3. So we know that f of 4 equals 3. This means that the point 4, 3 is on both the tangent line and the function. So the next thing we're trying to find is f prime of 4. Specifically, this is the derivative at x equals 4. That's what that f prime means. And this is the slope of the tangent line at x equals 4. So remember, derivative is the same as slope of the tangent line, or instantaneous rate of change. So looking at our line, the slope is the 6, that mx plus b form, so it's the 6. That means our derivative at 4, f prime of 4, equals 6. So what this tells us is that the point 4, 3 is on the function, it's also on the tangent line, and the slope of the tangent line is 6, so the instantaneous rate of change at x equals 4 of our function is 6. Alright, so that's it for this video. You can look at the next 2 example videos to get some more information about writing the equations of tangent lines. Thanks for watching, and I'll talk to you in the next one.